looking at number 2 in section 2.2. They want us to consider this function limit as t goes to 0 cosine t minus 1 over t squared. And right now we can only do this either numerically, so with a table, or graphically with our calculators. So I want to make sure that my mode is in radians, so I hit mode button on my calculator and I check to see that it's in radians. And then I'll go back to the y equals and I'll type the function in. I have to put the numerator or the top of the fraction in parentheses, and I'll use an x instead of a t. And then minus 1, close that parenthesis, and then divide by x squared. And they tell me the numbers that they want me to approximate. They do notice that h of t, this function is what we call an even function, because if you put like 1 or -1 in for t, you're going to get the same value, and that's because the cosine is an even function, and -1 squared and 1 squared are both the same, so you're just going to get always the same value. So when you go to your table, you don't have to put the plus or minus in. You actually can just put either the positive or the negative in. But let me show you what I mean. Like if you type in 0.002, and the reason they chose 0.002 is because that's close to 0, and we're looking for the limit as t goes to 0. Or you put -0.002 in, notice you get the same value. And so it's not necessary for you to put both positive and negative of the other numbers in unless you want to just to confirm that. So we got the 3 zeros, and then there's 4 zeros, and then a 5, and then 4 zeros, and then a 1. And you can put the positive and negative in if you want, but you should see that you get the same value. And you do in fact get, it looks like -1/2. And if you move your cursor onto it, it's at .001, it's -0.4999 repeating, and they rounded it to -0.5. All right, so we could probably argue that this limit, I'll bring this table down here, is equal to -1/2 by the numeric analysis. If you wanted to look at the graph for fun, remember I like to look at Zoom 4 for the window. And what they're asking is, as t goes to 0, so as the x value gets closer and closer to 0, where is this y value? And you should be able to argue to yourself that it does appear to be at 1/2. You can kind of trace, see at -0.1 it's -0.495, and you can kind of, obviously at 0 it's undefined, but then right near it on the other side is that -0.4. So that's another way to sort of look at it. That's your graphical approach.